x squared minus 4 equal x plus 2. Solve for the x. So move over, get x squared minus x, move 2 over, minus 6 equals 0. Factor it, minus 3 plus 2. So x equals 3 or negative 2. When x equals 3, y equals 5. If x equals negative 2, y equals 0. So the two are the two function intersection points. And that's the first one, draw the graph. Second one, B part. Find the area of the region enclosed by the graph by the two functions and the vertical line. X equal a constant is a vertical line. X equal negative 1, x equal 2. X equal negative 1 is this vertical line. X equal positive 2 is this vertical line. So enclosed by function, f function, and the g function, and the vertical line. So it's the find out the area in here. The area in here is going to be the upper function minus the lower function, and take integral from a to b. So a is negative 1, b is 2. So the area is equal integral from negative 1 to 2. Upper function is f function, f of x, minus lower function, g of x, dx. Then integral negative 1 to 2, f of x is x plus 2, minus g of x is x squared minus 4. Take integral. Remove the parentheses, minus change to plus. Then put them in order. Negative x squared first, then x. Then 2 add 4 is 6. Take integral from negative 1 to 2 dx. Negative x squared, take integral is negative power rule. 2 add 1 is 3. 2 add 1 is 3. X, take integral 1. 1 add 1 is 2. X squared. 6 take integral 6x. X go from negative 1 to 2. Then 2 plug in x, get this, minus, and put a bracket. Negative 1 plug in, get this, and use bracket. And then figure out. And this 2 cubed negative a over 3, 2 squared, 4 divided by 2, 2. 6 times 2 is 12. Minus this negative 1 cube, it's negative times negative positive 1/3. Negative 1 squared is 1 plus 1 over 2. 6 times negative 1 is minus 6. Then this 2 add 12, get 14. Remove the parentheses, this is a minus 1/3. Plus change to minus. Minus change to plus. And figure out this. Negative a third, negative 1/3, negative 9/3, get negative 3. And the 14, then minus 1/2 plus 6. And figure out this, get 33 over 2 is the area between two curves. Next, find the area of the region enclosed by the graph by the two functions. So area of the region enclosed by the two functions. So if you look at the graph, by f function and by g function enclosed by the two functions is going to be this area, enclosed by the f function and the g function. It's this area. And that area, the x go from -2 to 3. That's why we need to find out intersection point, the two function intersection point. Then will be f function minus the g function, and the x go from -2 to 3. So the area will be go from -2 to 3, the f function minus g function, this. And this we already figure out in previous one. In here we figure out already. This take integral is this. And now change boundary from -2 to 3. Then you plug in. This we call fundamental theorem of calculus. 3 plug in into x minus -2 plug into the x. And that's 3 cube 27 over 3 -9. 3 squared 9 over 2. 6 times 3 is 18 minus -2 cube 8. -8 times positive 8 over 3. -2 squared 4 over 2 is 2. 6 times -2 is -12. And then -9 add 18, it's 9. 9 over 2. Remove the parentheses. Minus a over 3. And this combined is -10. Remove parentheses plus 10. Then this add this 19. And the 2 add together. The 2 add together times 3 both sides times 2 both sides. Get 11 over 6. Add this together is 125 over 6. You can live in proper fraction. You don't need to go decimal. You don't need use calculator. Go decimal. You don't go to the mixed number. Then next one, question 8. Demand, consumer surplus, and the producer surplus. So the quantity demand X in units of 100 of the sportsman 5/7 per week is related to the unit price P in dollars by the relation. P is in price, unit price equal in terms of X, how many units. This is the demand function, D of X. You can see this is a decreasing function because here minus go decrease when X plug in. 40 minus those. When X increase, the price, X increase, demand increase, the price decrease. So demand function is a decreasing function like this I draw here. This is a demand function. This here is X, how many units. This is a price. Price in terms of X. P in terms of X. When X increase, the price decrease. So I draw this D of X decrease function. Decrease function. And you can see it's a decrease because here's 40 minus X increased minus, then the price becomes smaller and smaller. It's decreasing function. So when X go larger and larger, the price goes small, decrease. And then because P is decrease, the quantity. This is a supply function. The quantity X in units of 100 that the supplier is willing to make available in the market is related to the unit price in dollars by this relation. And this is a unit price equal. This is supply. how many units? X units. This is increasing function. When x go larger and larger, 20 minus those positive number. So it's an increasing function. And this is when x equals 0, started at 20, started as a small 20. This x equals 0, this is started as higher. So demand function start at a higher position, higher than supply function. So this is supply function is increasing function. When x go larger and larger, the price go larger and larger, increasing function. And the two function finally intersect at one point. And this point we call equilibrium. Equilibrium points. Equilibrium points. Equilibrium points, and then unit, we use x bar. And price, unit price, use p bar represent. And that's intersection points. Equilibrium points. X bar is equilibrium quantity. P bar is equilibrium price. So, and here say assume the market price is set at equilibrium price. So A, find the equilibrium quantity and the equilibrium price. So that means the price are equal, unit are equal, intersection points. So we let, because price equal, so we let the two are equal. D of x equal P, price equal. So D of x equal S of x. Demand and the supply are equal. So that's this negative 0.1 x squared minus x plus 40 equals 0.1 x squared plus 2x plus 20 equal. Solve for the x. Solve for x, I move this over, combined, get 0.2 x squared, move this x over, change the sign, become 2x, add x, get 3x. 40, move over, change sign, get minus 40. 20 minus 40 is negative 20, equal this side 0, equal 0. Then because here has a decimal number, so it go to whole number, so times by 10, they move one position, become 2. This times by 10, 30. This times by 10, 200 equals 0. Have a common factor 2. Those are even numbers, so divided by 2. Get x squared plus 15 minus 100 equals 0. Factor it. 10 you can factor as 20 and negative 5. 20 times two number times together is negative 100, is 20 and negative 5. Times it's negative 100. The two number add together is 15. 20 add negative 5 is 15. So that's factor. And factor get x plus 20 times x minus 5. So then either, since x plus 20 equal negative 20, it's invalid. Because x is how many units, a negative number, we don't use it. So use positive number, x equal 5. That is the x bar. Equilibrium units quantity is 500. 500 tanks. Here it's per week. 500 tanks, because in units of 100. So it's 500 tanks per week. Then x equal 5, you plug into either this demand function or supply function, either one. They are equal, so price will be equal. So P equal S of 5 equal 0.15 squared plus 2 times 5 plus 20. So get 32.5. That is the P bar. Equilibrium price is $32.5. $32.5. So then find the consumer surplus. Because here say if the market price is set at an equilibrium price, which is a P bar. So if your market price is $32.5, then your demand and supply are equal. The units is 500 tanks per week. So that's this point. So here, X bar is 5. P bar is 32.5, this intersection points. And here, figure out the consumer surplus. What is the consumer surplus? Is this demand function? If you take integral, is 0 to X bar. That's going to be this demand function d of x, and we figure out this this supply function s of x, and figure out this is x bar and p bar. Here it's x, here it's p function. Now if you got this is x bar, this is 0. If you take integral, d of x from 0 to x bar dx, that is going to be this area. Then you have to surplus means is over this. In market price is here it's x bar, here is x bar, here is p bar. So minus this area, x bar, p bar. That is going to be consumer surplus, CS. So consumer surplus is integral 0 to x bar d of x dx, which is this entire area minus this area, and it's this area, consumer surplus. Because what is the d of x? D of x is a price per unit price times dx. Dx is how many units is sold, is consumer demand unit price so much, and times how many dx is how many units, and that's total how many dollars. And then go from 0 to x bar. That's consumer, and minus in the market. The market is x bar times p bar, and that's the surplus, consumer surplus. So d of x is function is negative 0.1 x squared minus x plus 40, and put over here, and dx. 0 to x bar is 5, minus x bar is 5, p bar is 32.5. So we'll get take an integral, negative 0.1 x squared, take integral is x cubed over 3, minus x take integral is x squared over 2, 40 take integral is 40x. X go from 0 to 5, minus the 2 times together, 162.5. Then this 5 plug in x, minus 0 plug in is 0. So figure out this, and minus 162.5. So surplus is 20.83 bar. Repeating. Then, because here the x is 100 in hundreds, since the x is how many x hundreds, so you have times by 100, because you times by x is in hundreds, so you have to times by 100. So move decimal, put to the right, because this is equals 20.83333, keep going on. So move decimal, put to the right 2 positions, and get $2,083.33 is consumer surplus. Then next, figure out producer surplus. Producer surplus is this is a producer. Assume we but actually sale, market sale is so much dollars. This one is for the this supply function, and this is a demand function, supply of x, this is demand of x, this is x bar, p bar, equilibrium points, here it's p bar, this is p, this is x. So in the market we sell total is this. Then originally the supply function is this, and times this is the area. This is the area is integral s of x 0 go x bar dx. That's suppose supply should sell so much dollars. It's a surplus, but actually earn it's x bar minus p bar, this one, and so get this supply producer surplus. So producer surplus is x bar p bar minus integral 0 to x bar s of x dx. Now actually in the market sale is so much dollars, 5 times 32.5 minus then the producer surplus willing to available in the market is can sell so much, integral s of x is this function dx, take integral, and then this get producer surplus ps, because here the demand function is so much, demand is so much, and then suppose you can demand is so much, so you take integral is under it, that is the how much dollars, but but actually on the market price set at this, then actually you sell is X bar. So then you subtract it, you got consumer surplus. And here, the other one is S of X is a supply. The supplier is willing to make available in the market is this. So under this is the supply willing to earn the money, but actually product on the market is sell so much. Then you minus this and get producer surplus. So then you this take integral and subtraction, and you got surplus is 33.3. That is 33.3333. Then you move decimal times by 100 because this x dx is in hundreds, like $32.5 times 5. 5 is 500. 0 to 5 is 0 to 500. X is hundreds, but here only use 5. So we have times 100. And so the producer surplus is $3,333.33. The next one is the Kai-Tay plans to deposit $4,000 per year in his defined benefit retirement account if interest is compounded continuously at the rate of 8% per year. How much will he have in his retirement account? This we call, we will use this formula. And this is the notes of chapter 6, integration. Here has integral formula. And you can see here consumer surplus formula, producer surplus formula. Here, we will use the 4 formulas here. Accumulated future value of an income stream. Formula is A equal e to the power RT integral 0 to t r of t e to the power negative RT dt. We will use this formula. Future value of an income stream. This formula to do. So I write over here, A equal this formula. Future, this is a deposit per year deposit, $4,000. So R of T is constantly $4,000 deposit in and compounded continuously at the interest rate. This is smaller r, 8%, negative 0.080 dt. And how much we'll have in retirement account after 20 years. So 0 to t, t is 20 years. And here is e to the power r, small r is 0.08 times t. T is 20 years. Plug it into the formula. So you got this 4,000 factor out, e to the power, this time together is 1.6. And this take integral, you divide by negative 0.08 e to the power negative 0.0t and go from 0 to 20. Then you plug the 20 in t. So it's here 4,000 divided by negative 0.08 is negative 50,000 e to the power 1.6. This 20 put it in t, and 0 put it in t, and subtraction. And you got negative 50,000 e to the power 1.6 times together negative 1.6 minus 1. And you can this multiply in, get e to the power 0, which is 1. And this multiply in e to the power 1.6. And you can multiply this negative in, get positive 50,000 e to the power, become positive e to the power 1.6 minus 1. And use a calculator, figure out. And you got so much dollars. And this question, because this r is in terms of t, change with t. T is in how many years? But since this is a constant, 4,000, so we can use another formula to do. If it is constant, put in, we can use this formula. Because amount of an annual t. A equal mp over r e to the power rt minus 1. This formula to do. So I put the formula over here. M means each year you deposit how many times each year deposit in. Since here per year deposit $4,000, so only one time. Per year, 1 year deposit one time. So M equal 1. P is 4,000. R is 0.08. Integral e to the power r is 0.08. T is 20 minus 1. Actually, then 4,000 divided by 0.08 is 50,000. And then this time this minus 1. Actually, this one is the same as this one. And subtraction, figure out. You can do this formula. If this r of t is constant, you can use this formula. This formula is actually when r of t is constant, you got this formula. When r of t is m times p, and you from this formula become this formula. Question 10. An investment generates a continuous income stream of r of t. Now this is not constant. We have to definitely use this formula to do. $1,000 per year for the next 5 years. The prevailing rate of interest is 3% per year, compounded continuously for this 5-year period. A, what is the future value of the investment at the end of 5 years? So use this formula. So e to the power r is 0.03, 3% times t. T is 5 years. Integral 0 to t, t is 5 years. And 20 e to the power 0.08, that's r of t, times e to the power negative r is 0.03 times t dt. And then this is 20 factor out, e to the power time together is 0.15, integral 0 to 5 e to the power, the two same base is e, add exponent 0.05 t dt. Then 20 e to the power 0.5, this take integral divided by 0.05, and then t go from 0 to 5. Then this 20 divided by 0.05 is 400, e to the power 0.15, and then this 5 plug in, get times by 5, and this 0 plug in times by 0. So you got 400 e to the power 0.15, e to the power 0.25 minus 1. Then you can distribute it in 400 still outside. This times 0.15 at 0.25 is 0.4. And this times in is e to the power 0.15. Then use calculator. And you got this. And since it is in thousand, so you have times 1,000, 3 zeros. Move decimal point to the right 3 positions. And rounding, truncate. So get 131,996.15 is the future value. The next one, what is the present value of the investment over the term of 5 years? Present value is in the formula here. Present value is this. Actually, is this part is present value. For the accumulated future value of an income stream, this part is present value. Present value actually equal this part. So as I write over here, present value integral 0 to t r of t e to the power negative rt dt. So equals integral 0 to 5 r of t. R of t is, this question is 20 e to the power 0.08 t. So plug it in here. Then e to the power negative r is 0.03 t dt. So will be 20 factor out integral 0 to 5 e to the power the 2 add together 0.05 t dt. 20 and this take integral divided by 0.5. T go from 0 to 5. Then 5 plug in, 0 plug in. 20 divided by 0.0, 400, and get this. And use calculator. And this have to go hundreds, thousands. So move decimal point to the right 3 positions up to here, round up. So I got $113,610.17 is present value. Number 11, find the amount of an annuity if $250 per month is paid into it for a period 20 years, earning interest rate at the rate of 4% per year, compounded continuously. So this question, you can use this formula or this formula because it is a fixed constantly per month deposit in $250 paid into $250. So you can use this. R of t is going 250 times 12 months, 1 year. R of t is 1 year rate. 1 year rate. So you deposit in how much dollars? 20 times 12 is a fixed rate. So here MP M is how many terms? Deposit in is 12 months times each month is 250. So this is a fix. So for R of t is a fix. Then is MP. After multiplication, you will get this. This formula, if R of t is constant, is MP. Then this you can, after integral, you will get this formula. So e to the power r is 4% is 0.04 times t is 20 years. Integral 0 to t is 20 years. R of t is 250 times 12 months times e to the power negative 0.04 t dt. So this multiply out is $3,000. E to the power this time together is 0.8. Integral 0 to 20 e to the power negative 0.04 t dt. So then this e take integral divided by negative 0.04 and t go from 0 to 20. Then plug in t, 0 plug in t. And then you this 3,000 divided by negative 0.04 get negative 75,000. Then e to the power 0.8, 20 plug in, multiply out, get negative 0.8 minus 0 plug in is 1. E to the power 0 is 1. Then you go negative distributed in, you go e to the power 0.8 distributed in, got e to the power 0, which is 1. and e to the power 0.8 distributed in 0.8, and negative distributed in get e to the power 0.8 minus 1, and figure out is this. Then here doesn't, here is exactly 1, so then up to here and round up, so it's $915.57. Or you can use this formula. M is 12, P is 250, R is 0.04, and e to the power R is 0.04 times T, 20 years minus 1. So this time, this divided got 7500 e to the power 0.8 minus 1, which is this one. This one. Then you don't need to go this procedure, directly got this one. And that's the same answer.